press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the next worked example problem in the permutation concept. This is the last one and very important problem for 5 marks question. Okay, so 16th worked example problem I written here once again. Firstly I write find the number of arrangements find the number of arrangements of the letter of the word independence in how many of these arrangements question number 1, do the words start right here. Question number 1, do the words start with P? Question number 2, do all the vowels occur together? Always occur together means occur together. Question number 3, do the vowels never occur together? Do the vowels never occur together? 4th question, do the words begin with I in the first place and end in P? These 4 questions are given. So you already solve all type of the construct. Start with P, vowels occur together, vowels never occur together, I in the first place, P in the second place, last permutation problem. All problems are over. This is the last problem and very important problem. We solve one by one problem we solve. Okay. One by one. Right here, solution. The word independence contains objects 2, 4, 6, 8, 2, 4, 6, 10, 12. The word independence contains how many objects? 12 objects. Okay. In which n repeated 3 times, 1, 2, 3, 1, 2, 3. E 3 times. D 2 times. Sorry, E is not 3, 4 times. Okay. The word for independence contains how many objects? 12 objects. N repeated 3 times, E repeated 4 times, D repeated 2 times. Firstly, the total number of permutations 12 factorial divided by 3 factorial into 4 factorial into 2 factorial. 12 factorial divided by 3 factorial into 4 factorial into 2 factorial. So 12 into 10 into what? 9 into 8, 7, 6, 5 into 4 factorial. Correct? 12 and one more I left here into 11. 12 into 11, 10, 9, 8, 7, 6, 5, 4 factorial. 4 factorial. 3 factorial. 2 factorial. 4 factorial. 4 factorial get cancelled. 12, 11, 10, 9, 8, 7, 6, 5. 3, 2, 1. 2, 1. 3 ones are 3 twos are. 2 to get cancelled. 2 ones are 2 fours are. 12, 11, 10, 9, 4, 7, 5. Correct? 12, 11, 10, 9, 4, 7, 5. Calculate. Calculate the answer. 12 into 11 into 10 into 9 into 4 into 7 into 5. 1, 6, 6, 3, 200. 16 lakh 63,200. 16 lakh, correct? 63,200. This is what the total number of permutation of the word independence. So we write this answer. This is very because we want here 16 lakh 63,200. Okay, first question. We start first question. Do the words start with P? Do the words start with P? So in the first place, P is fixed. Correct? Total number of object is what? 11. The total number of permutations 11 factorial divided by 3 factorial, 4 factorial, 2 factorial, 11, 10, 9, 8, 7, 6, 5, 4 factorial divided by 3 4 factorial, 2 factorial, 4 factorial, 4 factorial get cancelled. 10, 9, 8, 7, 6, 5, 11, 10, 9, 8, 7, 6, 5, 3, 2, 1. 2 1 3 ones are 3 twos are 2 get cancelled 2 ones are 2 fours are 11 10 9 4 7 5 11 10 9 4 7 5 multiply these values. So 11 into 10 into 9 into 4 into 7 into 5. The answer is 13,86,000. 1 lakh 38,600. 1,38,600. First question is over. So answer is 1,38,600. Understand? 1,38,600. Next, second question. All vowels occur together. All vowels occur together. In that, E and I are the vowels. All vowels occur. Second question. All vowels occur together. How many E's are there? 1, 2, 3, 4. I. Total is 5. So 12 minus 5, 7. 5 plus 7. 7 plus 1 is 8. All vowels occur together. Required number means the total number of arrangements. 8 factorial divided by E is left out. 3 factorial into 2 factorial into, here the placement is different. How many objects are there? 1, 2, 3, 4, 5. 5 factorial. In this 5 objects, this is very important. In this 5 objects, E is repeated how many times? 4 factorial. This is the answer. 8, okay. Total number of 12 minus 5, 7. 7 plus 1. 7 plus 1 is 8. Not here, this one, sorry. 7 plus 1 is 8. 8, okay. 8 factorial. In that 8 factorial, we left out E, N is repeated 3 times, D is repeated 2 times. In this object, how many objects are there? 1, 2, 3, 4, 5. 5 factorial. But E is repeated 4 times. So the required answer. 8, 7, 6, 5, 4, 3 factorial. Divided by 3 factorial, 2 factorial. 5 into 4 factorial divided by 4 factorial. 4 get cancelled. 3 get cancelled. 4 get cancelled. 3 get cancelled. I write here. That is equal to 8, 7, 6, 5, 4 divided by 2 into 1 into 5. Into 5. 2 ones are 2 twos are 8, 7, 6, 5, 2, 5. Multiply the answer. 8, 7, 6, 5, 1,68,000. Oh, sorry, 16,800. So answer is 16,800. In this, watch, vowels are what? Occur together. So this answer is 16,800. 16,800. Second question is over. Second question is over. Third question. Do the vowels never occur together? Very simple. The total 16,63,200 minus 16,800. If you subtract this one, the total, very simple. Sixteen lakh 46,400. 16,46,400. This is over. 16,46,400. Third question is over. Understand? So third question is over. Do the word begin with I, end with P? On the last question we left out. Do the word begin with I? Do the word begin with I, end with P? So, in the 12 arrangements, I in the first place, P in the, I think fourth question now, P in the last place. 12 minus 2, 10. The total number of arrangements. N factorial divided by, n is repeated how many times? 3 factorial, 4 factorial, 2 factorial. Calculate. N into 9, 8, 7, 6, 5, 4 factorial. Correct? 10, 9, 8, 7, 6, 5, 4 factorial. 3, 4, 2. 4 factorial get cancelled. 10, 9, 8, 7, 6, 5 divided by 3, 2, 1, 2, 1. 3 ones are, 3 twos are, 2 get cancelled, 2 ones are, 2 fours are. 10, 9, 4, 7, 5. 10, 9, 4, 7, 5. Calculate. 10 into 9 into 4 into 7 into 5. 12,600. So last answer is 12,600. See the question one by one. 12,600. This completes the concept of permutation. Very important concept we finish up. Only one concept we left out, that is combination. We continue. We take the next concept in the chapter permutation and combination. Firstly, observe the previous problem, this problem. Very, very important problem for 5 marks. So we continue. The next concept, combinations. Last concept in the chapter, permutation and combinations. The last concept, combinations. So permutation means what? Arrangements. Correct? Permutation means what? Arrangement. Combination means what? Selection. If anybody asks, Define combination, selection of an objects. Define permutation, arrangement of an objects. That is the difference. Difference between permutation and combination. Permutation means arrangement of an objects according to the definite order, taken some at a time or all at a time. What about combination? Combination means selection of an objects according to the definite order, some at a time or all at a time. Combination means what? Selection of an objects. Okay, combination. Combination means selection of an objects. For that, observe here. We have 4 alphabet letters A, B, C, D. A, B, C, D. So we have to select 2 at a time, 4 objects, 4 digits. Select 2 at a time. 2 at a time. Which one is? EB. One selection. Here very important point. In the permutation, position is important because we have to arrangement A in the first place, B in the second place. In the combination, selection, in the combination, position is not important. AB selection same as BA selection. Correct? Both are same. That means in the combination, position is not important. Whereas in permutation, position is important. Permutation means arrangement. A in the first place, B in the second place. It is different from B in the first place, A in the second place. In the permutation, AB is not equal to BA. In the combination, AB is equal to BA. Both are same because we have to select. Here we have to arrange. Very important concept. In the permutation, arrangement position is very important. In the combination selection, position is not important. So combination means selection. Okay. So 4 objects are there. We have to select 2 at a time. One is AB. Okay. Then AC. Then AD. A is the A fix, not first place, second place. A must be fixed. Then I have to fix B. BA. AB is over. BC. BD. Then C. CD. DA is there. Okay. So 1, 2, 3, 4, 5, 6. Total number of selection is equal to 6. This is what the combination. Combination means selection of an objects taken some at a time or all at a time. Selection of an objects taken some at a time or all at a time. So 4 objects are there. We have to select 2 at a time. So AB, AC, AD, BC, BD. So total number of combination is 6. So this can be denoted by combinations denoted by n number of objects. We have to select R at a time. Here also R is greater than or equal to 0, less than or equal to n. Is very important. Combinations are denoted by NCR. What we denote in the permutation? NPR. Same way, combination, selections of an objects taken some at a time or all at a time is denoted by NCR. N number of objects. We have to select. R at a time is denoted by NCR. So for example, here 4 objects are there. we have to select 2 at a time. So we can denote it by 4C2. Correct? 4C2. The answer is 6. 4C2. The answer is what? 6. So overall, combination means selection of an object. Permutation means arrangement of an object. What is the difference between permutation and combination? In the permutation, positions are very important. In the combination, positions are not important. Okay, then combinations, n number of objects taken r at a time, where is r is greater than or equal to 0, less than or equal to n, is denoted by what? Ncr. Ncr. Okay, so we have to write the formula. Okay, so for that what I do, so combination definition is over, selection. So this is what? This answer is selection. Selection means this answer is combination. I derive the formula. Combinations. So same permutations, same objects, 4 objects taken selected 2 at a time. So I have to find out 4P2. 4C2 we got the answer is 6. 4P2, 4 factorial divided by 4 minus 2 factorial. You know the formula, correct? 4 factorial divided by 2 factorial. So 4 into 3 into 2 into 1. 2 into 1. 2 to get cancelled. 4 3 is 12. So answer 4P2. 4P2 is equal to what? 12. 4C2 is what? 6. 4P2 is what? 12. So same permutation, combination. So now we have to derive the formula. N number of objects taken r at a time. NCR is what? NPR we know. N factorial divided by n minus r factorial. So I club these two results. So I write here 4P2 is equal to how much term? 4C2 into 2, correct? 12 is equal to 6 into 2, correct? 4P2, so see this result. 4C2 is what? 4C2 is 6, 4P2 is 12. So 4P2 is equal to 4C2 into 2, correct? So this we can return as 4P2 is equal to 4C2 into 2 we can return as 2 factorial. 2 factorial. So 4C2 and cross multiplying 4C2 we can return as 4P2 divided by 2 factorial. Correct? 4C2 is equal to 4P2 divided by 2 factorial. By that implies NCR is equal to NPR divided by what? R factorial. NCR is equal to, and comparing this result, R is what? 2, N is what? 4. Comparing these two results, NCR is equal to NPR divided by R factorial. Correct? NCR is equal to NPR divided by R factorial. NCR is equal to formula NPR, N factorial divided by N minus R factorial whole divided by R factorial. You know NPR. NPR is what? N factorial divided by N minus R factorial. That implies NCR is equal to what? N factorial divided by N minus R factorial into R factorial. This is the formula. n number of objects we have to select or at a time n number of objects we have to select or at a time is given by n factorial divided by, solve by using this concept what we discussed in the example, n factorial divided by n minus r factorial into r factorial. So n where r is what, greater than or equal to 0, less than or equal to n number of objects, okay, select r at a time is given by Ncr is equal to one more formula, n factorial divided by n minus r factorial into r factorial. So the formula for combination n number of an objects we have to select r at a time is given by n factorial divided by n minus r factorial into r factorial. First formula, n number of objects we have to select r at a time is given by n minus r factorial into r factorial. So I can use the example, okay, I can use the example to derive the combination formula. Then note, first note, after knowing the formula, first note, what is the relation between permutation and combination? Observe this one, 4p2 is equal to 4c2 into 2 factorial. Similarly, if I write 4p3 is equal to what? 4c3 into 3 factorial. By seeing this result, the relation between, very important, the relation between, first note, the relation between, after deriving the formula, okay, the relation between permutation and combination is given by npr is equal to Ncr into r factorial, or r Ncr is equal to npr divided by r factorial. This is the what? Very important one, very important relation. What is the relation between permutation and combination? What is the relation between what? Permutation and combination. npr is equal to what? Ncr into r factorial, or r Ncr is equal to npr divided by r factorial. This is the note number 1, the relation between permutation and combination. Formula for combination is Ncr is equal to what? N factorial divided by n minus r factorial into r factorial. First note is over. Second note, one by one we write, one side we write, one by one we detailed displays. Very important. First formula, n factorial divided by n minus r factorial into r factorial. This is first one, correct? Second one, relation between permutation and combination, r factorial. Relation between permutation and combination is npr is equal to ncr into r factorial. Okay, so note number second, I think. Okay, what? nc0, if r is 0, nc0, we substitute here n factorial, n minus 0 factorial, 0 factorial. See, observe here, n factorial into n factorial. Why it is 0 factorial is 1. N factorial get cancelled. nc0, it is always 1. nc naught, if r is 0, very important result. If r is 0, suppose for example 100 c0, directly write, it is 1. 1000 C0, 10 lakh C0, it is 1. If R is 0, N whatever it may be value, it is 1. Third 1. NC0, it is 1. If R is 0, the result is 1. Okay. Next one. I think fourth one. NCN. We will see this one also. N factorial divided by N minus N factorial into N factorial. N factorial divided by 0 factorial into N factorial. Get cancelled. Again it is 1. See the result. NCN means R is equal to N. R is equal to N. The combination result is 1. For example, 10C10, it is 1. 100C100, that is also 1. So very important result. Fourth one. NCN, that is also 1. NC0, 1. NCN, 1. Understand? So, fifth note, very important, fifth one. NC0 over NC1, that we don't know. We solve this one also. N factorial divided by N minus 1 factorial into 1 factorial. N into N minus 1 factorial divided by N minus 1 factorial into 1 factorial. N minus 1 factorial, N minus 1 factorial get cancelled. NC1, N divided by 1 factorial. NC1, N divided by 1 factor. Suppose I want 10C1, 10 divided by 1 factorial. 100C1, 100 divided by 1 factor. 1 factor is 1, okay. NC1. So what? N divided by 1 factorial. Fifth result. These are all very important results. That's why I write one side. NC1. NC1 is what? N divided by 1 factorial. Okay, 1 is over. Next, I think sixth one. NC2. That I don't know. N factorial divided by N minus 2 factorial into 2 factorial. N into N minus 1 into N minus 2 factorial divided by N minus 2 factorial into 2 factorial. N minus 2 factorial, N minus 2 factorial get cancelled. N into N minus 1 divided by 2 factorial. This is very important result. NC2. NC2 is what? N into N minus 1 divided by 2 factor. Suppose I want 10C2 for example. 10 into 10 minus 1 is 9. 9 divided by 2 factor. Suppose I want 100C2. 100 into 99 divided by 2 factorial. So, sixth result, NC2. N into N minus 1 divided by 2 factorial. N into N minus 1 divided by 2 factorial. By seeing these two results, if you want seventh one, NC3, then N into 1 less N into N minus 1, N minus 2 divided by what? 3 factorial. N into N minus 1, N minus 2 divided by what? 3 factorial. These are all results are very, very important. So one more result. Very important result. If I think seventh, eighth one. If NCA, NCB, very small result. NCA is equal to NCB. Then A is equal to B. If this condition satisfies, NCA is equal to NCB, A is equal to B, or N is equal to A plus B. Very important result. Very, very, very important result. NCA is equal to NCB. NCA is equal to what? NCB. Under this condition, A is equal to B. Both are same. If A is not equal to B, A is not equal to B. If suppose A is not equal to B, then N must be equal to what? A plus B. This is one very important note. NCA is equal to NCB. We use this one. Okay. NCA is equal to NCB. Then A is equal to B. Under this condition, A is equal to B or N is equal to what? If A is not equal to B, N is equal to what? A plus B. I think 8th, 9th note, NCR plus NCR minus 1 is equal to N plus 1 CR. So, we are not understanding properly, sir. For that, what I do, 3 is okay, 4C3 plus NCR. NCR minus 1 less, 4C2. This one, 5C3. N plus 1 CR. R is what? R is 3. N plus 1 is 5C3. We will check out all the result. Firstly, we find 4C3. 4 factorial divided by 4 minus 3 factorial into 3 factorial. 4 into 3 factorial divided by 1 factorial into 3 factorial. 3 factorial get cancelled, just answer is 4. 4C3 is 4 plus. So 4C2. 4C2 and C2. 4 into 3 divided by 2 factorial. 2 ones are 2 twos are. 3 twos are how much? 6. 4 plus 6. Okay, 4 plus 6. So 4 plus 6 is what? 10. So we will find out, this is what? 10. Okay, we will find out 5C3. 5C3. So 5 factorial divided by 5 minus 3 factorial into 3 factorial. 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. 3 factorial, 3 factorial get cancelled. 5 into 4 divided by 2 into 1. 2s are 2 2s are get cancelled. 5 2s are 10. So this is nothing but what? 5C3. This is nothing but what? 5C3. Observe this result. This result is very, very important. NCR, both N are same. NCR minus 1 is less. Observe 4 4 same, 3 2. So this result is always equal to, this result is always equal to what? N plus 1 CR. These two notes are very important. NCA is equal to NCB. Either A is equal to B or N is equal to A plus B. NCR plus NCR minus 1, it is equal to what? N plus 1 CR. NCR plus NCR minus 1, NCR plus NCR minus 1, it is equal to what? N plus 1 CR. Understand? All these notes up to 9th notes are very, very important. First one is Ncr formula, n factorial divided by n minus r factorial into r factorial. NPR, the relation between permutation and combination. NPR is equal to NCR into r factorial. NC naught is 1, NCN is 1, NC1 is n by 1 factorial. NC2 is n into n minus 1 by 2 factorial. NC3 n into n minus 1 n minus 2 divided by 3 factorial. NCA is equal to NCB. A is equal to B. Or n is equal to a plus b. And very important role, NCR plus NCR minus 1, it is always equal to n plus 1 CR. So once again I explain, combination means selection of an objects taken some at a time or all at a time. So in that combination, position is not important. Okay. After knowing this concept, we solve the problems one by one. I think exercise 7.4. Exercise 7.4. First problem. If NC8 is equal to NC2, find NC2. NC8 is equal to NC2, find NC2. So, okay, solution. Given NC8, NC2. So, since NCA is equal to NCB, that implies A is equal to B or N is equal to A plus B. Correct? N is equal to A plus B. Here A is not equal to B. That implies N is equal to A plus B. 8 plus 2. Answer is 10. N is equal to what? 10. What he asked? He asked NC2, 10C2, 10 into 9 divided by 2 factorial. 10 into 9 divided by 2 into 1. 2 ones are 2 5s are. So answer is 45. Very simple question. Observe this problem. I use this result. I use this result to find what? NC2. So 10C2, 10 into 9, 4 into 9. So answer is 45. First question is over. Next question. Second question. Determine N if first, 2NC3 is to NC3 is equal to 12 is to 1. 2NC3 NC3 is equal to what? 12 is to 1. So this is what given. 2NC3 divided by NC3, 12 divided by 1. Because A is to B, we can turn as A by B. A is to B, we can turn as what? A by B. So I use this result. 2N into 2N minus 1 into 2N minus 2 divided by 3 factorial. Because note, NC3 we can turn as N into N minus 1, N minus 2 divided by 3 factorial. 12 divided by 1. 3 factorial what? Get cancelled. 3 factorial get cancelled. What left? 2N. 2N minus 1. In this term, I take 2 common. N minus 1. Divided by N minus 1, N minus 2. 12 divided by 1 or 12. So N get cancelled, N minus 1 get cancelled. Okay, 2 2s are 4. 4 into 2N minus 1 divided by N minus 2 is equal to 12. 4 1s are 4 3s are. Cross multiplied, 2N minus 1 is equal to 3 into N minus 2. Correct? 3 into N minus 2. Multiply. 2N minus 1, 3N minus 6. Shifted 3N from right side to left side. 2N minus 3N minus 6 plus 1 is how much? Minus N minus 5. So the answer N is equal to what? 5. Observe this simplification, very important. N is equal to what? N is equal to 5. This is very important concept. I use NC3. Note, NC3 n into n minus 1 into n minus 2 divided by what? 3 factorial. N into n minus 1 into n minus 2 divided by what? 3 factorial. Next question. In that second question, Nc3 11 is to 1. 2Nc3 Nc3 is equal to 11 is to 1. 2Nc3 divided by Nc3 11 divided by 1. 2n into 2n minus 1 into 2n minus 2 divided by 3 factorial. First one is over. Whole divided. N into n minus 1 into n minus 2 divided by 3 factorial. 11 divided by 1. 3 factorial get cancelled. 2n into 2n minus 1. In this term, 2 take common. N minus 1 whole divided by n into n minus 1. N minus 2, 11 by 1. So, n minus 1 get cancelled, n get cancelled. So, 2 into 2, 4 into 2n minus 1 divided by n minus 2, 11 divided by 1, correct? So, cross multiplying. 4 2s are 8n minus 4. 11n minus 22, correct? On multiplying 11n minus 22, shifted 8n minus 11n minus 22 minus plus 4, because minus into minus plus, so shifted from left side to right side, it becomes minus 4 becomes plus 4. 8n minus 11n, 8n minus 11n minus 3n. Minus 22 means 18. N is equal to 6. The value of N is equal to 6. Observe this problem, very important problem. Observe this problem. N is equal to what? 6. Up to this we stop. We continue the remaining problems in the next class. Thank you.